AI is reading chest x-rays now, and in some hospitals it's actually pretty good. But here's the uncomfortable truth. It's not equally good for everyone. These models are quietly biased against certain racial groups and genders. And the scary part? Most people building these systems don't even know it's happening. Here's why bias creeps in. Medical datasets are skewed. The majority of chest X-ray data comes from white patients. So the model sees way more examples from that group, learns richer features for them, and predictably performs worse on everyone else. But it gets more subtle than that. Disease prevalence itself varies across demographics. Cardiomegaly, for instance, is more common in Asian patients. So if the model isn't careful, it doesn't learn this patient has cardiomegaly, it learns this patient looks Asian and Asian patients tend to have cardiomegaly. That's a spurious correlation. Now these models aren't just image classifiers, they are CLIP models. They jointly learn from images and radiology text reports. That adds another surface area for bias to sneak in through the image text alignment process itself. So how do you fix this? The key idea in AdFair-CLIP is adversarial training, and the intuition is elegant. Think of it as a two-player game. You have your main model, an encoder, trying to learn good disease representations. And you introduce a second network, a discriminator, whose only job is to look at these representations and predict is this patient male or female, black, white or Asian. Now here's the adversarial twist. The encoder wants the discriminator to fail. If the discriminator can easily read off demographic information from the feature space, that means demographic information is baked into the representations, which is exactly what causes bias. So the encoder is trained to make its representations as uninformative as possible about sensitive attributes while still being maximally useful for disease detection. Mathematically, this is a minimax problem. The discriminator is maximizing its ability to predict demographics and the encoder is minimizing it, while simultaneously minimizing the contrastive alignment loss between image and text pairs. What makes AdFair-CLIP distinct from prior work is where this intervention happens. Previous methods tried to debias at the similarity score level, a pretty shallow fix. AdFair-CLIP goes directly into the feature space, which means the bias is suppressed at the representation level and that carries through to every downstream task. And crucially, both the image features and text features are fed to the discriminator jointly. We concatenate the text features and the image features. And as a result, even when radiology reports don't explicitly mention race or gender, the image text alignment process can implicitly encode demographic signals. So you have to attack the multimodal representation, not just the visual one.